Hi guys, so for today's discussion, this is the second part for our line balancing topic wherein we're going to balance the line by identifying the allocation of the number of operators that can be assigned in each operation. Now, as a review, to compute for the efficiency of the line, so we can use the formula, the summation of the standard time divided by the summation of the allowable time or the longest task time in the operation. Now, this is just the same as the formula for our efficiency of the balanced line wherein we multiply the allowable cycle time by the number of stations. Now, let's just have a simple example for the efficiency of the line. So, let's say we have three operations. Operations 1, 2, and 3. And you are given the following standard time in minutes. So, let's say we have 4, 2, and 3. So, para makuha yung total standard time, so we'll just get the sum of your ST, which is 4 plus 2 plus 3, which is 6 plus 3. We have 9 minutes. And then the summation of your allowable time. So, given that the longest task time is 4 minutes, so we multiply that by the 3 operations. So, we have 12 minutes. So, the efficiency, therefore, is 9 over 12, then multiplied by 100 to get the efficiency in percent form. So, that will give us 75% efficiency. Then, for the number of operators in the line, so we have two formulas here. So, the first one is assuming that we have 100% efficiency. So, we'll just multiply R, or the desired rate of production in units per minute, then multiplied by the sum of the allowable time. Now, for a realistic approach, so we will be using a value for efficiency, and normally that is 95%. Now, usually in problems, naka-indicate naman kung ano yung efficiency na gustong ma-achieve ng line na iyon. So, for this given example, we have 8 operations with their respective standard time in minutes. Now, we have the total available time of 480 minutes, which is usually an 8-hour shift. And then the production demand is 700 units. So we want to determine the total number of operators and the output of the line. So for our solution, so we have our available time at 480 minutes, and then your required output so you first need to compute for the cycle time. So cycle time is your available time divided by the output, which is 480 minutes divided by 700 units. And that will give us a value of 0.68 6. So we use at least 3 decimal places for this one. And then your rate of production is just the inverse of the cycle time, which is 700 units divided by your 480 minutes which is 1.458. So again, don't forget the unit. So this is minute per unit, and this is unit per minute. So we'll now proceed with the second part of the solution, which is the computation of the total number of operators in the line. So ito yung ating given information, and we will be using the formula of your N, which is your R, multiplied by the sum of your standard time divided by the efficiency. So again, wala naman nakalagay na indicator or wala naman naka-indicate na efficiency dun sa problem. So we'll just use 95% for a more realistic approach. Now, from our previous solution, again, yung ating rate of production is given as 1.458. So your N is therefore 1.458, then multiplied by the sum of our standard time. So kapag inad natin silang lahat, so that will give you a value of 15.37. So which is here, divided by 0.95. So your N is 23.59 or 24 operators. So again, we always round up our answers when we compute for the theoretical number of operations or operators or stations in the line. So once we know the total number of operators in the line, the next step is to find the number of operators for each operation. And that is by dividing your standard time with our cycle time. So kung matatandaan from the previous solution, our cycle time is your 480 minutes divided by 700 units, which give us an answer of 0.686. Now, for us to know the number of operators for operation 1, we'll just divide 1.25 by 0.686. And that will give us a value of 1.822. So, para makuha naman yung actual number of operators, we always round off this answer. So, from 1.822, since i-round off natin siya para maging whole number, so it will give you an actual number of 2 operators for operation 1. So, for the second operation, ganun ulit, 1.38 divided by 0.686, and that will give us 2.01. So, dahil round off ito, so yung 0.01, hindi siya pwedeng i-round up into one whole number, so it will remain as 2. So, next operation 3. So, actually, we can have a faster solution to this one by using the calc function from your calculators. So, you can assign the 0.686 as the constant number, and then yung standard time will become your variable data. So, for operation 3, so input lang natin sa calculator 2.58, and that will give you 3.76 for 4 operators, followed by for the next 5.60. So that will give you 6 operators. Then 1.27, that's 1.85. So that's 2 operators. So tuloy lang yung ating process. So pag after natin ma-round off, we can add the total number of actual operators and it should be around the same number of our computation for n kanina, which is the theoretical number of operators in the line. Now, take note that the theoretical number of operators can be, or your actual number of operators can be higher or around the value of your n, kasi yun lang naman yung theoretical, so yung actual can still be varying. So once we already know the total number or the actual number of operators assigned in each line, so we go now to the third step, which is finding the slowest operation of the line. So we add another column here, which is the ratio, and that is just the quotient or the value by dividing your standard time with the number of actual operators for each line. So that will be 1.25 divided by 2. So that will give us 0.625. Next operation, 1.38 divided by 2 again. That will be 0.690. Then 2.58 divided by 4. That's 0.645. So after getting the ratio for all operations, so we will be looking for the highest number. And in this case, we can see that 0.690 is the highest number, which gives us the idea that operation 2 takes the longest time to finish. So once we identify the longest operation of the line, so we now go to the fourth step, which is determination of the output of the line, and that is by using the formula, the number of operators of the longest operation divided by the standard time, and then we multiply by the available time. Now looking back, so ang ating operation 2, which is the longest operation, has 2 operators, and ang standard time is 1.38. Now, take note that the total available time is given in minutes as well, which is 480 minutes. So, again, kung ano yung ating standard time unit, so dapat yun din yung unit ng ating available time. So, again, for us to know the output, so we have 2 operators, then we multiply by 480 minutes, then divide by yung 1.38 minute. So that will give us a rough estimation of 695.65. And again, when we talk about outputs, we always round down or dropping the decimal value. So that will give you 695 units for the output of the day. So that's units per day. So syempre, if you want to know the output per hour, so we will just divide that by 60 or divide it by 8, since you have 8 hours per day. That will give you 86 or 86 units per hour. And that's the end of the solution for the determination of the number of operators for each operation and the number of output of the line.